Example 2. For this question, for this square, we've applied double integral. We got our answer. We got 0. We've gotten 0 when we use double integral. Now we want to use line integral. As well. We want to use line integral, meaning we must also get 0. If we get 0, it means that my Green's theorem is verified. If I'm not getting 0, it means my Green's theorem is not verified. So we can watch the first video. When we use double integral, we got 0. Now let's use line integral. You must also get 0. If you are not getting 0, just state that your Green's theorem is not verified. Alright, now from this question, it is stated here that we have a square bonded. We have a square bonded, right? You know, for the previous one that we've done for triangle, we've done for a curve. Now, for this square, I said earlier on that any given question, you are given any questions here on Green's theorem, that question, your task is the same way you implement mathematical approach to it, meaning formula, you're also implementing a graphical approach. So this question now, say you are drawing using line integral, you must, it is a must, right? You must represent this question using what? Graphical approach. Using graphical approach, meaning the closed curve for this question. It is expected that this closed curve must be a square. It is what expected that it must be a square. Now, draw your graph. Let's draw our graph, since that's our first task. Let's say this is my graph. Say this is y. This is my origin, meaning 0, 0. Now, how it works is that I'm just plotting the value of x and the value of y. If x is 0, meaning I have value of x here to be 0, right? Then for 1, x is 1. Let's say I have 1 at this point. Let's say I have 1 at this point. You know, okay, let's say I have 1 at this point. Then y is 0. Of course, let's say I have my 1. Let's say I have 1 for this point. Just like we've seen when we did our triangle, I've explained in details. If this is your first time seeing our video on Green's theorem, check other examples. Check the one for triangle, check the one for curve. Particularly, check the one for triangle. I've explained it in full details. Alright, now what we are just doing is that we are using our normal mathematical approach. We are giving the value of x to be 0 and 1. So when x is 0, I have it here. When x is 1, I have it here. When y is 0, I have it here. And when y is 1, I have it here. Now, at each point that you've indicated the given value, just now at each point, you have a corresponding value of x and y. If from the question, at each point, you have value of x, meaning at that same point, you must have a corresponding value of y. Similarly, if from the question, you have value of y, at that same point, you must have corresponding value of what? X. So, following what we said this is x, right? At this point, say this is point A. I'm having the corresponding value of x at this point A to be 0 and for y to be 0. Now, let's say this is point B. I must have the corresponding value of x and the corresponding value of y. So, if x is 1 at this point, y will be what? 0. Because there's no way I can get the value of y here. Y is what? 0. Now, at this point, if y, at this point, if y is 1, x will be what? X will be 0. Meaning I have 0, 1. Hope that's taken. This is what we are following. X and y. So x comes first, then y follows. Since we know that we are dealing with square, meaning I will trace this point. Let's say this is A, this is B, and this is D. Meaning I'm going to trace this point together to give me a square. And what I'm having here, if I join the points respectively, I'll be having triangle. But from the question, it says what? Square. Meaning there's a particular point at this place. You have a point here. Meaning at this point, I must know the value of x and y. But before then, we determine what this value of x and y is. You just draw your curve. Say you draw a perpendicular line at B, and you draw a vertical line at B, and you draw a horizontal line at D. So the point of intersection, meaning you must know the value of, let's call that point C. Meaning at C, you must know the value of what? X and y. So looking based on what we have, if this place from here, based on what we have, it is obvious that x and y here will be 1, 1. True or false? True. X is 1, y is 1. This is x, trace it up. This is 1. Trace your x up here, you have 1. Trace your y here, you have 1. So this is what? 1, 1. So what we just did is that given any question on Green's theorem, represent that question using what? Using your graph. Represent that question graphically. So this is what? your graphical illustration to this given question. And always we said this is my close curve, right? When we did the introductory, we stated the theorem, we defined the left hand side, we defined the right hand side. We said C is a what? Mathematically I have this theorem as what? Integral C all into bracket Pdx plus Qdy equals to double integral R all into bracket dq over dx minus partial derivative of p with respect to y multiplied by a. So now I'm saying that this C, this R, this is this region that you are seeing. This region that you are seeing, it is the R. Then this C, it is the curve, which is this square curve bonding this R. That's what this theorem is stating basically. And this C is moving in a counterclockwise direction. This C is moving in a what? Counterclockwise direction. Though not necessarily you move in counterclockwise direction always. You can move in clockwise direction. But when you are moving in clockwise direction, your value of your limit will change. So you are working based on the direction you are going with. So the common movement is counterclockwise. So we moving in counterclockwise does not mean you cannot move in clockwise. You can actually move. What will change is your sign convention. But the common movement you always see is what? Counterclockwise. So that's why we are adopting that idea. Then we moving in counterclockwise direction. We are saying against our work log. So let's say this is my origin. So I'm moving like this: A to B, B to C, C to D, and D to A. So let's say from A to B, this is C1, B to C, this is C2, C to D, this is C3, and D to A, this is what? C4. So the whole idea is that this is actually line integral, this is line integral, and this is double integral. We've implemented double integral, we've gotten 0. So by the time we implement line integral, I must get 0. So the whole idea is that you implementing this line integral C open bracket P dx plus Q dy is equals to integral of C1 plus integral of C2 plus integral of C3 plus integral of C4. So meaning your movement, the way you are going, let's say A to B, this is C1. This is you perform line integral to that segment, to that movement. You are moving along A to B, which is C1. You also perform line integral to BC, which is C2. You also perform line integral to CD, which is C3. And you also perform line integral to DA, which is C4. So that's what we are saying. So we say segment A, we represent this as segment A, we represent this as segment A, we represent this as segment B, we represent this as segment C, and we represent this as segment D. So whatever approach we are applying to segment A, we also apply the same approach, or you say the same method to segment B, segment C, and segment D. Nothing is changing. Nothing is changing. Now you observe, we want to apply this formula, right? And this formula, what are the unknown? You have P to be the unknown, Q to be the unknown, the X to be the unknown, and the Y to be the unknown. In this case, you are given P and Q. You are given P and Q. From the question itself, this is P, this is P, this is Q. In this case now, the P and Q have been substituted in your line integral. Normally, what would have been given to us is that the vector field are given as x square I plus s square j, meaning this is P. Take note that P is always I, meaning I direction, while Q is always what? J. From that question, this is what would have been given. But the question has made it easy for us. This is y square. So the question has made it easy for us in the sense that the question has substituted P and Q directly into line integral. But to know your P and Q, if it is not given, just do comparison. The given question, this is the given question. The given question is what? Integral y square dx plus what? X square dy. Just do comparison. This is the given question. Given, right? Given question. Do comparison between the given question and the formula of line integral, which is integral p dx plus q dy. From here you can deduce. By the time you do comparison, you have this cancel out, this cancel out, this cancel out, this cancel out. You are left with what? P equals to y squared. You are left with what? Q is equals to what? X squared. So that's what we are saying in essence. So in general, we are saying that P is equals to what? Y squared, and Q is equals to what? X squared. Now in this case, I already know the P, I already know P, I already know Q, meaning at each segment, I'm going to make use of this formula and I'm going to substitute the value of P and Q. Just that P and Q, they are constant. P and Q is constant. But in this case, what varies is the X and the Y. So you are applying the idea of differentiation. You want to get the X and you want to get the Y. A function must have been differentiated. A function must have been what? Differentiated. So let's say you are giving Y. Let's say you are giving Y to be X squared. By the time you differentiate this, you have what? The Y over the X is equals to 2X. Cross multiply, right? Meaning the Y is equals to 2x dx. So what you are saying is that before you can know the Y, a function must have been differentiated. Before you can know the X, a function must have been differentiated. Now the question is, how do you know this function of Y and X at each segment that you want to apply this line integral to? So this is where the idea comes. You have two methods. You have the shortcut method and you have the parameterization formula. By parameterization, you apply formula for X and Y. You can watch triangular method. We already solved parameterization approach using triangle curve, and we also make use of the shortcut approach. We've done that, right? It's not actually called the shortcut. It's something that you looking at your curve, you'll be able to estimate, you'll be able to know the function. You looking at your curve, you will know the function of X and you will know the function of Y. So that's why we say it is the shortcut approach. So that's how it works. Now let's determine the function of X and Y at each segment. Let's apply line integral to each segment and do the necessary evaluation for your integral function. For segment A, for my segment A, meaning when we say segment A, meaning integral C1, so I have my line integral formula as c y square dx plus x square dy. So we are using this directly. So what I just need here is that I need the function of x and I need the function of y. By the time I know the function of x and y, and I need my limit also, I need the lower limit, and I need the upper limit. By the time I know the function of x and y, I'll differentiate, I'll substitute. By the time I know the upper limit, I'll substitute and differentiate, and for me, I'll substitute and perform my definite integral. Now, we said segment A, meaning C1. Come back to your curve. This is C1. It is from A to B, right? From A, we have 0, 0, and you have 1, 0. Now, the idea is that you have x coordinate and what y coordinate. This is x, this is y, this is x, this is y. I'll be explaining the previous example. So we are still using the same concept. For example 1, we've explained. Now, the next example, right? So now, from here, you observe that at A, this is what? B. You observe that from A, x is 0. For B, x is 1, meaning x is changing. For y, x is 0 at A. For B, y is still 0. Y is 0 at A, y is 0 at B, meaning y is not changing. Meaning y is constant, or you say y is fixed with a value of 0, or you say y is constant with a value of 0. Now, since x is changing from 0 to 1, just that any coordinate that is changing, you substitute it as t. Any coordinate that is changing, you substitute it as t. So since x is changing, I have x equals to what? T. Then y is not changing. Y is not changing with a value of 0, meaning y is fixed with a value of 0, meaning y is equals to 0. So what I mean is that for segment A, this is the function of x. For segment A, this is the function of y. Now differentiate. By the time you differentiate this, the x is equals to what? The t. By the time you differentiate this, the y is equals to 0. Now, how do you get your lower and upper limit? You will determine your lower and upper limit based on the movement. Determine the lower and upper limit based on the coordinate that is changing. So you said S is changing. It is changing from what? 0 to 1. Meaning it is starting at 0 and it is ending at what? 1. The coordinate that you are using in this case is not necessarily always it is X. It might be Y in some cases. But at this instant, I'm using it is X that is changing. At the starting point where S is changing, it is what? 0. Where it is ending, it is what? 1. Meaning where you are starting is your lower limit, where you are ending is what? Your upper limit. Meaning that your lower limit in this case, X is equals to 0, and your upper limit, X is equals to what? 1. So these are all what you need for segment A. All these values that you've estimated, substitute it in the line integral for segment A. Meaning you have 0 to 1, you have y squared. What's your dx? dt plus what's your x? Your x is what? Plus, I'm having x squared. Your x is t here. If x is t, x squared becomes what? T squared dot what? dy. Your dy here is what? 0. And you've gotten x to be t and y. You've gotten x. Okay? You have plus x squared dot what? dy is what? 0. And you already know the value of x and y. If x is t, meaning if x is t, meaning x squared is equals to t squared, and y squared is equals to what? 0 squared. So substitute that here. You have integral 0 to 1. What's y squared? 0 squared dot dt plus t squared 0. Okay, there's nothing I want to integrate. This will cancel out. So meaning I have this integral as 0. So my first integral for segment A, performing line integral to segment A, I have 0. Now let's perform line integral to segment B. Let's perform line integral to segment B. Similarly for segment B, I'm performing line integral to segment B. When we say segment B, meaning B to C, that is integral C2. Same idea. Write out your line integral formula, meaning integral y squared dx plus x squared dy. From here, you need your y function and your x function. By the time you know these two functions, you'll be able to get the x and you'll be able to get what? The y. And you also need your lower limit. You need your lower limit and you need your what? Upper limit. Now, in this case, your interest should be the coordinate for your segment B, meaning segment B, it is moving along B to C. So it is starting from 1, 0 to what? 1, 1. This is x, this is y, this is x, this is what? Y. From here, you observe that this is B, this is what? C. Now, same idea. I want to know the function of x and y. The one that is not changing becomes the value that you have there, meaning the coordinate that is fixed with a particular value becomes that same value, whereas the one that is changing becomes what? T. Now you observe that at the starting point x is what? 1. At the ending point x is what? 1. Meaning at the starting point x is 1. At the ending point x is 1. Meaning x is not changing. So in this case, you have your function of x to be what? 1. But now at the starting point y is what? 0. At the ending point, y is what? 1. Meaning y is changing from 0 to 1. That is, y becomes what? Y becomes t. Therefore, the x is equals to 0 and the y is equals to what? The t. Now, how do you get your lower and upper limit? Your lower and upper limit is based on the one that is not changing. Meaning, since y is not changing, what is the value of y when you are starting? Meaning the point of y when you started, then the point of y when it ends. From here, you have that y is starting with 0 and y is ending with 1. Meaning that your starting point, your lower limit takes what? 0 and your upper limit takes what? 1. Right? Writing this in a proper way, you have that t is an element of 0 to 1. So substitute all this in your line integral formula, meaning integral 0 to 1 y squared. What is y squared? If y is equals to t, then y squared will be what? T squared. Also, if x is equals to 1, x squared will be what? 1 squared. So substitute all this into your line integral formula. 0 to 1 y squared, meaning t squared dot, what is the x? 0 plus what's x squared? 1 square. What's the y? The t, right? Now, in this case, what do you have? This cancel out, you are left with what? Integral 0 to 1, 1 dt. 1 square will give you what? 1. By the time you integrate this, you have t, right? Integral of 1 is what? T. Meaning, you've integrated, you got what? T. Substitute your lower and upper limit. Meaning that 1 minus this, and this is equals to what? 1. This is equals to what? 1. So for the first segment, which is A, we got 0. For the second segment, we got what? 1. Now, same idea. For the last two segments, that's what you are going to apply. I want to believe you already understood it now. Alright, so let's work this together. For segment C, meaning C3. So now, let's get the function of y and x. Write out your vertices. You are starting from C back to D, meaning 1, 1. On getting to D, you have 0, 1. This is x, this is y, this is x, this is y. From here, which one is changing? Y is changing from 1 to 0, meaning y, meaning x takes what? S takes t. Why is it t? It is taking t because it changes. It is changing. Now, from here, y, y in this case is fixed with the value of 1, meaning y is still 1, meaning the function of y is still 1, which is the value that y is fixed with. Now, from here, if this is x, if x is equals to t, the x will be what? The t. If y is equals to 1, the y is equals to what? 0. Also, if x is equals to t, x squared will be what? T squared. If y is equals to 1, y squared will be what? 1 squared. Then our limit, in this case, your y is not changing. In this case, your x is not changing, meaning your limit depends on x, which is the one that is not changing. But observe, your starting point is what? 1. Your ending point is what? 0, meaning this line is along 0 to 1. So you have x to be what? Your lower limit to be what? The starting point, which is 1. Your upper limit to be what? 0. So writing this, you see this as t is an element of 1 to what? 0. Now, from here, substitute all this in your line integral formula. So I have that my line integral, my limit comes first, 0 to 1. What's your y square? 1 square. What's your dx? dt, right? Your dx is dt, right? Plus what's your x square? Meaning t square. Dot what's your dy? 0. Obviously, this man here is out of it. So I'm left with integral 0 to 1. 1 square is still what? 1. Then the t. Now integrate this. Integrating a constant, which is 1, you have what? T. Substitute your lower and upper limit, meaning 0 to 1. I have 0 minus what? 1. So I have what? Negative 1. So this is for segment. So this is for segment C. So far I've done segment A, segment B, and segment C. Lastly, let's do for segment D. Let's solve for segment C. When we say segment C, meaning what? C4. Try pausing this video and try for segment C yourself. Try pausing this video and try segment D yourself. Try segment D yourself. You should get the same thing. You must get your answer. Then once you've gotten your answer, then play this video and correlate it to what we'll be getting. So if you are correct, it means you already understood the concept. You've understood the concept. And know that this applies to whatever curve it might be. If it is triangle, and if it is triangle or rectangle or square, this applies. This is still the same concept. All right. I want to believe you've gotten your answer. Now segment D. To get my y function and my x function, my segment D, meaning C4, it is moving from D to A. So I have 0, 1 and 0, 0. So this is x1. Okay, this is x, this is y, this is x, this is y. In this case, x is fixed. X is not changed. This is the starting point, which is D, and this is the finishing point, or let's say the ending point, which is A. So for the starting point, x is 0. For the ending point, x is 0, meaning the function of x is still 0. For the ending point, for the starting point, y is 1, and y has changed towards 0, meaning in this case y is equals to t. Now differentiate, the x is equals to 0 and the y is equals to what? The t. Let's get our limit. Our limit depends on the one that is changing, meaning the non-fixed coordinate. The non-fixed coordinate. In this case, y is the non-fixed coordinate. I am starting from 1, meaning my lower limit is what? 1. I am ending at 0, meaning my upper limit is what? 0. Writing this, we have this as t is an element of 1, 0. Right? And if x is equals to 0, x squared is what? 0 squared. If y is equals to t, y squared is what? T squared. Therefore, substituting all this in your line integral formula for segment D, you have that 0 to 1, 0 to 1, okay, what's your y? This is t squared, multiplied by what's your dx? 0 plus what's x squared? What's x squared? 0 squared, multiplied by what? What's dy? Dy is what? Dt. Alright, this is easier for us because in this case we can't integrate. This cancel out, this cancel out. Therefore, I have, or this implies towards 0. So I want to believe that this is what you got. You got 0 as well. So if you get 0, it means you understood the concept now. So you are correct. Alright, now so far we've done for segment A, segment B, segment C, and segment D. So add up all your values that you've gotten. Meaning, right, adding all contributions. Adding all contributions, meaning that when we say contribution, meaning integral c, which is what? P dx plus q dy, which is equals to the first one plus integral c2 plus integral c3 plus integral c4. For the first one, when we did the first one, we got what? What was our answer for the first one? We got 0. When we did the second one, we got positive 1. When we did the third one, we got negative 1. And now we got what? Positive 0. Meaning from here, this cancel out. I have what? 0. Now, in this case, let's answer the question itself. The question says that, given this question, does this question verify Green's theorem? What condition will this question verify Green's theorem? It will verify Green's theorem if only and if my answer for line integral is equals to my answer for double integral. So I implemented double integral formula to this question. I got 0. Now line integral, I got 0. Meaning that therefore, for this given question, line integral is what? Verified. Line integral is verified. So right, Green's theorem is verified. Green's theorem is verified. S Green's theorem is verified. In some cases whereby your Green's theorem is not verified, don't be afraid that you've done the wrong thing. Don't be afraid that you've done the wrong thing. It happens. So if in that case, just make sure that check yourself. All my steps, am I doing what I'm supposed to do? If you are certain that okay, what you've done so far, you implemented the right steps, meaning you are actually correct. It's just that for that particular question, Green's theorem is what is not verified. So for that type of question, also state it. So for this question, we've stated it that Green's theorem is what? Verified. It is verified because my answer for line integral is equals to my answer for what? Double integral. Alright, so this comes to the end of this video. If you find this video helpful, share your thoughts in the comment section and do well to give this video a thumbs up. See you in the next video.